Now that we know what an absolute value is, we're going to find out how to solve the equations. What cute little toes she has. Let's get into it. So, if I asked you, what two numbers have an absolute value of 5? We know, well, absolute value just makes something positive, so 5 could work, of course, and negative 5 would also work. There are two numbers that are going to make the absolute value of that be 5. Well, it turns out that we can generalize this. We can have any sort of garbage in here, and we can use the same exact logic. And that's what we're going to do for these absolute value equations. For example, example 7, right? We can have all sorts of things inside this absolute value equation, but notice that this will only be true when the inside is equal to 5. Or, right, if the inside was negative 5, then we'd have the absolute value of negative 5 right here. Right? If the inside were negative 5, this would be the absolute value negative 5, which would also satisfy the equation. And this is true as long as the right-hand side is positive. We'll get into that after this question. So there's going to be two answers in general for a lot of these. We know how to find them. It's just like that. We'll add 6 to both sides. We'll add 6 to both sides. We'll divide by 2. And we'll divide by 2. 11 halves and 1 half are our two solutions, or 5.5 and 0.5. However you want to write them, let's box them together. There you go. You could check your answer, plug that in. Hopefully both of them would check out. So in general, if we have an equation that looks like this, the absolute value of something equals something else, as long as that something else is not negative, we're going to have solutions when either the inside is equal to the right-hand side or the inside is equal to the opposite of the right-hand side. This is just restating this in more formal words from the book. With this in mind, we always try to get the absolute value by itself. So in example 8, we're not in this form. If we can get it into this form, we can solve it. So we need to get it into this form. The absolute value of something equals something else. We can never touch what's on the inside of the absolute value. Okay? Can't touch inside of the absolute value. There are ways that we can like factor, but we're not really going to cover that. In general, you don't touch it. All right? It's like messing with outlets, right? Don't mess with it unless you really know what you're doing. Electricity in general, I think. Okay, so let's get the absolute value by itself. We'll do that by adding 7 to both sides. So 7 is the absolute value of 4x plus 1. Now the absolute value is by itself. So this is going to be the case when the inside is equal to positive 7, that would work, right? When this is positive 7, that'll work. And if that were negative 7, it would also work. So when 4x plus 1 equals positive 7, and when 4x plus 1 equals negative 7. We can solve both equations. You get 4x equals 6. We'll get x is 3 halves. You can solve both equations. 4x is equal to negative 8. You can get x is negative 2. Put both answers together. They should both check out. Graphically, we can look at this as well, right? When is absolute value of 4x plus 1 minus 7? When is that equal to 2? Oh, I think I typed it in wrong. 4x plus 1 minus 7. When is that equal to 2? Well, when our input's negative 2.5, and when our output is 2. Wait, hold on. 4x plus 1 minus 7. When is that equal to 0? I was getting real scared there for a second. When our input's -2 and when our input is 1.5. Great. Absolute value functions always look like V's. They'll either look like positive V's if the absolute value is positive in front, or if we put a negative here, then it looks like a negative V. I mean, upside down V. Okay. So let's do the next one. Say this only works for B, the right-hand side. That's not negative. What happens if it is? Example 9 has the answer. Let's get the absolute value by itself. So we subtract 2 from both sides. Can't divide by, well, we could divide everything by 4, but let's subtract 2 first. That'll be easier. We get -1 is 4 times the absolute value of x minus 2. Bless me. And now the absolute value is almost by itself, but we do need to divide both sides by 4. So -1/4. Okay. So what does the inside have to be? Not worry about x. Just what does the inside have to be for the absolute value of it be negative? Panic. Nothing. Absolute value is always positive, right? Absolute value, I'm not going to write it like that. Absolute value is always positive or 0. It's never going to be negative. This can never happen. No value of x is going to make this equation true. Try it. Plug in some x's. Never going to happen. This is impossible. Okay. And unlike the Rodgers and Hammerstein version of Cinderella, impossible things are not happening every day here. The musical reference. I hope somebody gets it. One person, at least. Anyway. No, I want to sing that song. There's no solution. No solution to this equation. No x works. If you plotted it, the absolute value equation would never be 1. Let's plot it. Yeah. When is 4 times the absolute value of x minus 2? Plus 1. When is this equation? Sorry, 4 x minus 2 plus 2. When is that equal to positive 1? When is the absolute value graph equal to positive 1? The smallest value this function ever gets is 0. Function is never going down to positive 1. This never happens. They never cross. That's how we can visualize that. So right now, pause the video. I almost certainly did not give you enough space for this. But find the horizontal and the vertical intercepts for this function. So remember the horizontal intercepts. That's where the vertical value, the output, is 0. The output is 0 when 0 is negative q plus 2 plus 3. That's when -3 is negative q plus 2. Multiply both sides by negative when 3 q plus 2. And that can happen when the inside is 3 or when the inside is -3. So we can write it both ways and find both q values. We'll get q is 1 and q is -5. So these are our horizontal intercepts. An input of 1, output of 0, and an input of 5 and an output of 0. Horizontal intercepts. Vertical intercepts, often thought of as y-intercepts, is going to be when the input is 0. So then C, you could write this as C of 0, C evaluated at 0, or just C. Remember, this is function notation, not multiplication. C is going to be negative 0 plus 2 in absolute values plus 3. Careful. Absolute values turn something positive. So this turns to positive, but there was still a negative before it. We're going to get CS to be positive 1. So the vertical intercept is at an input of 0 and an output of positive 1. And those are all 3 intercepts. The 2 horizontal intercepts, 1 vertical intercept. If you graph this function, you're going to see the same thing. Let me know if you have any questions, and bye-bye.